Hello and welcome back for the last episode in our series on web service design. We have gone through a lot and we have finally reached this episode where I will be covering a whole bunch of separate topics. So these topics have very little connectivity, relationship between themselves, but they are all different, all the remaining pieces which needed to be touched upon to sort of wind up this entire issue of how we design web services. The first of these topics is database transactions. Now, we all have studied in colleges about the ACID properties of relational databases and the transaction boundaries that are important for us to have reliable data capture in the data store. It's all textbook stuff. But the reality is that when you work with a team of programmers of mixed levels of maturity, then where to put the database transaction boundaries, where do you start your transaction, where do you end it, is not something which is very obvious or very clear to all your team members. So when you have such a team, when you need to have careful transaction boundaries, especially when you are not doing something very simple, then you need to take care to make sure that there is a certain level of scrutiny applied to every database transaction in your web services. Most web services, half the web services only pull out data from databases. So there is no transaction data integrity challenge there. Out of the other half, most web services will just write one or two records into one or two tables in the database. Even there is very little to think about. You start your transaction at the beginning, do your updates and writes and inserts, and put a commit at the end. Job is done. So nothing much to worry about. But the remaining 2% or 5% of web services need to update different tables in strange ways, need to pull out data from one table while making sure that that data is not updated in parallel by anybody else. So you do a select for update, then you look at the data, then you go ahead and update certain other records somewhere else, and all of this reading, writing, updating has to be done in an atomic way. So when you have challenges like that, when you have web services which are complex in that way, then you need to very carefully manage your transaction boundaries. So the industry approach that we see all around us is to not think about transactions. When you talk about transactions to a practicing professional software engineer from the industry, most of them will say, oh, we don't really bother about them. We use Hibernate, and Hibernate takes care of all this transparently. The truth is that nobody really understands what Hibernate is doing when they say, oh, Hibernate takes care of it transparently. Those who understand what Hibernate does for transactions will never say, oh, we don't worry, Hibernate does it automatically. Their explanation of Hibernate's transaction management will be very different. So when you see the bulk of developers in the industry fairly clueless about what is happening with their transactions, you know you need to worry. And the reason why applications keep getting developed in very large numbers without too many crashes, too many data corruption episodes is because, as I said, only 2% or 5% of web services have a challenging data update regime where they need to manage transactions very carefully and consciously. So we have certain rules which we would put on the table. As a web service designer, the first rule to follow is one web service, one transaction. Well, one web service can have multiple transactions too, but you cannot have one transaction spanning multiple web services. So in general, to keep life simple, one web service is one transaction. Don't try to play around with this. So if you're not clear about this, then just treat it as a rule from us and just stick to it very carefully. The second, is each transaction must begin and end in the same web service. That's just another slightly different way of putting across the same idea. A transaction must begin and end within one web service only. Okay? Now there are all sorts of complications that happen sometimes when you cannot apply these rules in a very simple and natural way. So most of the time we find that I'll give you an example. You are inserting a purchase order into a system. A purchase order is just one example. There are many things which work like this. You are inserting a purchase order into the system. So a purchase order has a purchase order table where there is one record per purchase order, and there is a purchase order details table where there is one record per line item in the purchase order. So if you are going to insert one purchase order in your database and that purchase order has 40 line items, then you will want to do one record in the purchase order table and 40 records in the purchase order details table, right? So there are 41 records to be inserted. In that situation, what is your web service like? What web service design have you done? In some cases, we have found some engineers have gone ahead and created two web services. One web service to update the purchase order table and insert one record there. Another web service to update the purchase order details table and insert the 40 records there. So they have defined two create or insert web services. One called the purchase order insert, which takes one purchase order data. Another called purchase order details insert, which takes an array of purchase order line items. And there are two web services. This is a bad idea, because the first web service will insert one record and it will close one transaction. The second web service will insert 40 records in another table and commit that transaction. There is no atomicity across these two. So in that situation, rethink your web service boundaries. So our simple answer to this situation will be, you must create one web service which takes the purchase order record and the line item records all in one web service, and then inserts 41 records in two tables as one transaction. Now you may say this is difficult to do. Sometimes you have to insert 2000 line items. You cannot do it possibly in one web service call because it may not be able to handle so much data. Fine. If that is your challenge, then use a temporary table and make multiple web services, all of which will add all the records into a temporary table. You don't care what happens with the temporary table. And make one web service, create one web service which says commit this purchase order to the final table. Now that one commit purchase order web service will pull out all the records, 2000 records from the temporary table, and transfer them to the main table in one transaction. So then the updates to the main table will be atomic. So you will still get the full power and the full consistency of the atomicity, even though you are updating a temporary table in chunks. If the system crashes in between, data loss from the temporary table is not a problem. But your main tables are never going to have inconsistent data. So database transactions need to be thought through carefully. And if you cannot follow the rule of one web service equal to one transaction, then you need to rethink your web service boundaries. So that's my take on database transactions and web services. Now, the next topic that I want to touch upon is service-oriented architectures. So in service-oriented architectures, you're partitioning the system into multiple services, multiple sets of web services. Each service is actually a bunch of web services, and each service has its own database. So you're partitioning the data. When you do that, you have to decide cross-service replication, which is fine. You take care of that because data needs to be replicated across services to be easily accessible. And master data typically will replicate across all services because master data is required everywhere. So you typically land up replicating your master tables across all services. One of the important things to understand when you are designing your web services is do not design a web service running in service number 1 to make an inter-service call to service number 3 synchronously. This is not a good idea. It really increases latency and slows down your system. This cascading of web services from the outermost web service then to the inter-service web services is a bad idea. So we have seen systems which have been designed like this. Don't do it. If you need to make updates from a web service running on service number 1 to something in service number 3 or service number 5, either pass a message so that the update happens asynchronously, or maybe think about actually restructuring your services such that what you have decided were 2 services now needs to be combined into 1. Or figure out some other way of doing this cross-service update asynchronously. Do not do them synchronously. So that was about service-oriented architecture and web services in that context. The third little topic I want to touch upon is access control. Access control is not about authentication. When authentication is complete, the system knows who you are. Now the system needs to decide whether you are permitted to do something which you are attempting to do. That's access control. So you write detailed specs in the processing section of your web services to implement the business logic of enforcing access control. Fine. That is the basic thing that you have to do, like the level 1 thing. At that time, one of the things you need to worry about is configurability. Access control rules are one of those areas which are notorious for changing. They change too much in a business because business rules change. Okay. So if you are going to hardcode your access control rules as if-then-else statements within your web service code, changing access control policies is going to be a nightmare. So in that case, it is best that you do not hardcode your access control rules inside your code. Use an identity and access management system, an IAM. We have an IAM which we always use in all our projects. It's been there for the last year or so. It's ID Shield. We call it Remedies ID Shield. It's an open source product. It is a derivative of a very well-known open source IAM called Keycloak. So you can use Keycloak. You can use our slightly extended version of Keycloak, which is called Remedies ID Shield. One area where Remedies ID Shield has a lot of features is in access control. Authentication in Remedies ID Shield is pretty much 99% the same as what you get out of stock Keycloak. But access control has some advanced features. So you can use ID Shield, but configuring the ID Shield tables is something that you have to do carefully by understanding your business rules. And your web service call will have to call ID Shield, get the response from ID Shield, and then enforce the response. So ID Shield is not going to enforce the access rules. ID Shield is going to merely tell you what are the access rules. So that is the interface, that is the partition between your web service and a good IAM. A good IAM cannot get inside your business logic and enforce your access rules. A good IAM will just tell you what are the business rules. Therefore, the business rules remain configurable. They remain outside your code. So they are easy to change. But within your code, you have to look at the response that comes from an IAM, and you need to then enforce or comply with that response, those policies. So we would strongly suggest access control rules in complex business applications need to be delegated to an IAM. The next point that I want to bring out is something related to access control. Not really access control, but yes, yeah, access control, but in a restricted sense, data visibility. So we are not talking, in access control we talk about, are you permitted to perform the operation that you are trying to perform? That's the classic way of describing access control. Data visibility is a specialized subset or a slightly derivative angle of the classic access control. What does data visibility tell you? It asks the question, are you permitted to view the data that you are trying to view? So it's very interesting. It's not an operation as a whole. It addresses the question, which of these records in this table are you allowed to view? That is data visibility. To give you an example, the sales head of your organization should be allowed to see all sales data. The North Zone sales head should be only allowed to see the North Zone sales data. The guy who is in charge of the NCR, the National Capital Region, which is a small subset of the North Zone, should be allowed to see only the NCR data. And the store manager should be able to see only the sales data of his own store. Now, this is a region-based data visibility rule set. What about a product-based data visibility rule set? Let's start with the same sales data. The guy who's in charge of retail products should be able to see retail sales data for the whole country. The guy who is in charge of wholesale industrial products should be able to see only the industrial product sales data for the whole country, but should not be able to see retail sales data. You see, all sorts of intermeshings and rules can come up in a typical large organization when it comes to data visibility. Now, how do you incorporate data visibility into your application? One of the ways in which we usually do this is by adding a column in the data table, where let us say the sales data is the example we are talking about. So let's keep talking about the sales data. In the sales data table, add a column which is a capability column. So that capability column specifies that anybody who has this capability can view this data. And associate with each user a bunch of capabilities. So when the user is querying the sales data, you look up the capabilities of that user and you see which are the records in the sales table which require these capabilities. If a particular record requires a particular capability to view it, and this guy who is trying to view the data has some 5 capabilities, out of which one is the capability here, then this record can be shown to the user. So this is the way you try to, implement data visibility rules. These can get fairly complex, and it is best to have a generic template or a generic framework by which you implement these. We have a certain way of implementing capabilities, data visibility rules through ID Shield in our products. So that is one area where ID Shield has added a whole layer in addition to, beyond the classic stock Keycloak. Keycloak does not seem to have that dimension in its functionality. But basically the idea is this: you need to have capabilities in the data tables and you need to have capabilities associated with each user. So this is an area which is a bit of a high risk, because if there is a bug in this code, then inadvertently you can disclose data to people who don't have the right to see that data, and this can lead to serious confidentiality breaches within an organization. If this is a financial institution, then the confidentiality breaches can be far more severe. So this is a matter which needs to be implemented carefully, and it is not a good idea to implement it by designing the framework from scratch for every business application that you develop. So it's best to think through it in a generic way and implement it once, or rather design it once and implement it carefully in every business application that you build. Now we come to an area which is not very glamorous, but it has hidden complexities and subtleties, and all of that shows up in the set of web services that you need to implement. So it's not just simple business logic, it's web services too. That is why we are here, in fact, right? We are talking about web services in this entire series. So this topic is the topic of implementing maker checker. This is a very common requirement. What this says is, that if one officer is entering some data in a system and updating some data in a system, his updates or his insertions will not be finalized until a second officer looks at them and approves those changes, approves that new record or approves the changes to the records. So a maker inserts data or updates data or makes the changes, and a checker approves them or rejects them. That's the whole idea. That's why the term maker checker is used. So the term that is sometimes used is don't trust 2 eyes, trust 4 eyes. 2 eyes of the maker and 2 eyes of the checker. That is the idea. So this has a, it has a two-way dimension to this. One reason for doing this is to cut fraud. So you will need to collude with at least one colleague in order to commit some fraud by doing some fraudulent update to the data. The other reason to do this is to cut mistakes, honest human errors. So how do you implement maker checker? One of the approaches is to have a table of pending approvals. So do not put your temporary data, temporary records in the same table where you put your approved and final records. You have a separate record for pending approvals. And understand that a maker checker implementation is not simply a maker checker. It can be a complex state machine. So there could be multiple states of the record that is being inserted or updated. It is not just a question of step 1, somebody inserts the data, step 2, somebody approves it. That is the textbook approach which college students will visualize. The real world scenarios we have seen in complex and mature business applications in large organizations is far more complex. There is a UX element to this also. The pending approvals should show up on the screens very frequently. If they are not easily visible, then the approvals do not get done for a very long time. So there should be some way you should be able to write a web service which pulls out all the pending approvals and passes them to the front end so that the front end can display the warnings in the appropriate places. Now look at the complexities of maker checker. Okay, the first question, can I edit a draft record? A draft record is a record I have created which is not yet approved. So we call it a draft. So the first question is, can I edit a draft record before it is approved? So I have created it, it is waiting for approval. At this stage, can I edit it? Different organizations will give you different answers to this question. The second question, can I edit somebody else's draft record? Which means you create a draft record and then you go on leave for 2 weeks. It's waiting for approval. In the meantime, some changes need to be done. Will that draft record be visible to me so that I can make those changes? Or will it have to wait for you to come back from leave and then make those changes, because the system will not show one person's draft to another person? So this is the second question. Different organizations will give different answers. The third question, do you need to support back and forth? The back and forth functionality, what is that? I create a draft record, my boss needs to approve it. So will it be a simple case of me creating it and the boss either saying yes, approved, or no, rejected? Will it end there? Or can my boss say that this needs to be corrected and push it back to me? Do I need to support that functionality? Where it is not a case of simple approval or simple rejection, it is a case of returning the record to the person who's drafted it so that he can make corrections and submit it again. This is again a question to which different organizations will give you different answers. The next question in a maker checker module, do you need to support comments? When I create a draft record and send it to my boss for approval, will the boss need the feature to write a comment against the record and then push it back to me? Or will my boss need the feature to write a comment and then approve it so that it is approved, but the comments remain with the record for future audits or future forensics? So is a comment feature required? Is a query response feature required? So this is again a dimension which varies from organization to organization. Then the next question that comes up is, will it always be 2 levels? Is it sometimes necessary for the draft record to be approved once at level 1 and then approved a second time at level 2, and only then will it become final? So do we need to support a 2-level approval? And if the answer to this is yes, then the next question which immediately comes up is there a need to short circuit it sometimes? Which means, under normal circumstances, I will create a draft, my boss will sort of conditionally approve it, and then it will go to the general manager or the vice president for the final approval. But are there situations where I will create a draft, and if the vice president feels the urgency for some particular approval, he can directly approve it without my boss doing a first level approval? So is there a need for short circuiting the multi-stage under certain circumstances? So all of these are complexities which come in a simple idea called maker checker. So don't believe that the maker checker is a simple module. And your web services need to drill down into these requirements, and the designs of the web services have to be done appropriately. Now you may think that this is all business logic. Why are we discussing this in a series on web services? It is because I have seen the complexity of this business logic immediately reflect in the richness and the complexity of the web services that we need to implement. It's not just business rules, it's also the richness of the interface. So that's about maker checker. What's the next point? The next interesting and important subsystem for which we often need to design web services is to support comments. What is a comment? A comment is a feature where any person operating on any object, say somebody operating on a voucher or a purchase order or a loan application or a bank account in a bank, can insert a comment against that record. Just that. The need to allow the user to write a comment which will then go into the system and remain with that record as long as the record is there. Is there a need for comments? If there is a need for comments, defining web services for this and the underlying data structures and database tables for this is fairly interesting. It's not very easy to implement. So comments can be per object, as in per bank account or per, as I said, voucher. That's a per object comment. It can also be per field. That I wish to add a comment against just the date field of the voucher. I wish to add a comment just against the customer ID field of the purchase order, or the customer address, the ship to address of the purchase order. I don't want to add a comment to the purchase order as a whole. So users may need to post comments at various levels. So you need a system-wide comments table, that much is certain. And inside the comment table, which will be system-wide, each comment will be keyed by object type and object ID. And optionally a third field, which is the field ID or the field name, if it is a field level comment. If it is an object level comment, it will be object type, object ID. So each comment in the comments table will have to be marked or tagged with object type and object ID. The next complexity which comes in implementing comments is that you should be able to highlight to me, I am a user, you should be able to highlight to me a comment which I have not seen differently from a comment which I have seen. Think about the challenge. There are 5 users who are seeing the same set of purchase orders. Some comments have been added to a particular purchase order recently. I have been on leave for the last 1 month. So others have seen those comments, but I have not. Now, when I come and view that purchase order, you need to highlight those particular comments for me, indicating that they are unread comments. But when others view that purchase order, they should view the comments as, well, boring, read. They are there, but they are not highlighted. So you need to track a scene flag against each user comma comment combination. So this is an additional overhead to implementing a comment module, and you probably need to design your web services carefully such that the list of scene comments or the list of new comments can be pulled out with one web service call when I reach a particular object. Otherwise, just sequentially scanning a massive comments table with millions and millions of comments is going to kill the system. So this requires some amount of intelligence to be able to implement a high performance comment system. And do you want to chain comments? Do you want to have a facility by which you mark that this comment is in response to that comment? So a kind of threading. Do you want to support comment threads? So IRT means in response to. Do you want to have an IRT field against each comment which points to some other comment record? So all of these are interesting facets of implementing a comments feature or comments dimension to business applications. We have done some of this work. We have found that it requires more than casual thought. The last point I wanted to touch upon, the idea of a trace and a span. These are invaluable for debugging. As we had highlighted in some earlier episode, a business application implemented in the form of web services is very difficult to debug because there is no straight line thread of execution. Web services are triggered randomly at random times in random sequences by external callers. Therefore, you have no track of what happened first and what happened later. When you have a problem with data consistency or data corruption, you need to piece together the sequence in which things have happened. And the only way to do that is to have a clear idea of each call which comes in and what happens as a consequence of that call. And that is done by using a trace ID. So the trace ID is passed by the caller of a web service to the web service from outside, and that is logged at every step internally within your web service code, including all the functions, all the modules of that code. Now, when things are a little more complex, when your web service needs to maybe call some external service like an IAM or a business rules engine or some other system, then one trace is being broken into multiple sub-threads. So there we create a new ID called span ID. So traces and spans are both necessary. Think about incorporating them into your web services, and you have to log each of them at every step of your execution. It is with the logging that these IDs become valuable, and it is because of these IDs that you can thread together a story, a sort of post-mortem story of what happened in what sequence where, which resulted in what you're seeing today. So traces and spans are vital for survival in a complex business application. With that, we come to a close of this series. I hope it was fun. We have touched upon a whole basket of different topics. The motivation for this series was because we realized that people are writing business applications left, right, and center, and web services are being specified and implemented in their thousands all over the place. But some are being done well and some are not being done well. And when we began looking at things which cause distress or difficulty, we began to see certain patterns, and we began to understand that we have a lot of learning which can be injected into this area of designing web services to make what we consider are better web services, more useful, more maintainable web services. So we decided to put all these thoughts together into this series, and that is what brought me here. I hope it was useful. I hope you will be able to pull out information, pull out insights from this for your future software development. I know that this series was not really very beginner friendly, but yeah, these are not things that the beginner really worries about. These are things which you begin to appreciate only after a few years of software design. Thank you very much for watching, and we'll see you again in one of our next series. Who knows what that will be. Thank you.